Hello grade 9. Today we will take thermal properties of matter by teacher Eman Ahmed. We will find out today what is the meaning of temperature, heat, and the internal energy, and what is the difference between temperature and internal energy and their units, and what is the thermometers and how thermometers work and how the thermometers are designed, what is the meaning of thermal expansion and the uses of the thermal expansion and the thermal expansions of solids, liquids, and gas. Let's begin. We have to know what is the heat and temperature and the difference between temperature and the internal energy. At first, what is the meaning of temperature? Temperature, it is a quantity that indicates how hot or cold the object is. What about heat? Heat, it is the energy which transfers from one object to another object if they are only different in temperature. So, the heat transfer takes place from the hotter object to the colder object. What is the meaning of the internal energy? Internal energy, it is the total energy of all the particles. What about their units? For temperature, it is Kelvin. Heat, it is Joule. And internal energy, it is Joule. Thermometer is a device that measures the temperature of the things, okay? It is made up of two parts. The first part, it is thermo, which means the heat. And the second part, it is meter, which means to measure. So thermometer used to measure the temperature of the things. We use it to measure our body's temperature if we are sick, or the temperature of our houses or the ovens. This is Galilee Thermometer, one of the earliest thermometers. Here we use the thermometer to measure the human body temperature. Okay? The first picture, it is a liquid glass thermometer. And the second picture, P, it is a liquid crystal thermometer. If we put a thermometer in a hot water, the molecules of the water is bombarded by a fast moving, and the thermometer here will absorb some of their energy till it reaches the same temperature as the water and gives a correct reading. The water here and the thermometer bulb are in thermal equilibrium. What is the meaning of thermal equilibrium? Thermal equilibrium describes the state of two objects, the object and its surrounding, that are at the same temperature, so there is no heat flow between them.
Clinical thermometer. In this module, you will learn about a clinical thermometer. Your forehead feels warm. You immediately suspect a fever. To be sure, however, you need to measure your exact body temperature. How would you do that? Well, with the help of a clinical thermometer, also called a doctor's thermometer. A clinical thermometer is usually made of glass and consists of a mercury-filled bulb inside at one of its ends and a fine capillary tube that looks like a thread running from the bulb to its other end. There is a small constriction in the neck close to the bulb. A clinical thermometer can measure temperature ranging from 35 degrees Celsius to 42 degrees Celsius or 95 degrees Fahrenheit to 108 degrees Fahrenheit. That's a pretty small range. You can get the temperature by reading the scale inscribed on the side of the thermometer. Let us now see how a clinical thermometer works. A clinical thermometer is usually placed inside the mouth for measuring body temperature. Because of the body heat, the mercury inside the bulb heats up, expands, and rises to a certain level in the capillary tube through the constriction. The new level to which the mercury rises indicates the exact body temperature. You may be wondering if the reading changes on removing the thermometer from the mouth. Well, it does not. The constriction prevents the mercury from flowing back into the bulb. You can also say that the mercury column breaks at the constriction and is unable to return to the bulb, thus remaining stationary in the tube. To reset the thermometer, you need to swing it sharply many times so as to make the mercury column return to the bulb. Why do you think mercury is used in a clinical thermometer? Mercury is used in a clinical thermometer as well as other thermometers for a number of reasons. First, mercury is a metal and thus it is a good conductor of heat. It starts to expand instantly on placing the thermometer inside the mouth. The expansion can be seen as a rising thread of mercury. Second, mercury remains a liquid at temperatures ranging from -39 degrees Celsius to 357 degrees Celsius. Hence, it can serve to measure a wide range of temperatures. At last, mercury does not stick to glass. Though using mercury in thermometers has advantages, mercury-based thermometers are considered risky. This is because mercury is poisonous. In case the bulb or the neck of a thermometer breaks, mercury can leak out into the mouth. This is why mercury-based clinical thermometers have largely been replaced nowadays with electronic digital thermometers or scanner thermometers. In this module you've learnt a clinical thermometer is a thermometer used for measuring body temperature. It is usually made of glass and consists of a mercury-filled bulb at one of its ends and a fine tube running from the bulb to the other end. The neck near the bulb has a small constriction. A clinical thermometer can measure a very small range of temperature ranging from 35 degrees Celsius to 42 degrees Celsius or 95 degrees Fahrenheit to 108 degrees Fahrenheit. When a clinical thermometer is placed inside the mouth, the body heat causes the mercury in the bulb to heat up, expand, and rise up the capillary tube through the constriction up to a certain level. The new mercury level indicates the exact body temperature. Mercury is used in thermometers because it is a good conductor of heat and expands uniformly. It can be used to measure a wide range of temperatures and it does not stick to the glass. Mercury-based clinical thermometers have largely been replaced nowadays with electronic digital thermometers or scanner thermometers.
If you want to see the correct reading for the thermometer, first you have to place it in contact with the object. Second, you have to wait 1 or 2 minutes to share the temperature of the object with the thermometer. So the thermometer here tells us about the average energy of the particles in the object. If the particles here are moving rapidly, the thermometer will indicate a high temperature. And if the particles here are moving slowly, so the thermometer will indicate a low temperature. The temperature here of the object is measure the average kinetic energy of its particles. Celsius scale. It is known as the Centigrade Scale. This is the original name for it. It's based on the boiling point and the freezing point of the water at 1 atmospheric pressure. Boiling point of the water, it is 100 Celsius degree, and the freezing point is at 0 Celsius degree. Okay? It is named after by Andreas Celsius in 1701 to 1744 before being renamed by Honor Andreas in 1948. The problem here with the mercury thermometers is that they have to be read by your eye. So, what is the solution? We have here to get an alternative thermometer which we have to use, such as the electric thermometer and the thermocouple. Here, this figure shows that the resistance of the resistors changes with the temperature. Some of these are based on the thermistor. So, the resistance of the resistors will change here with a large amount over a narrow temperature range, and its behavior is not linear. Calibrating a thermometer. How can we calibrate the thermometer? First, we have to fill a container with a finely crushed ice. Then, 2, you have to put a clean tap water and stir well. The third one, immerse the thermometer stem into the ice at a minimum of 2 inches for 30 seconds. The steam here shouldn't touch the sides of the container and the bottom of it. If the temperature here is reading -1 degree Celsius, you are the way to checking your thermometer is calibrated correctly. Types of thermometer. There are different types of thermometers such as probe, laser, oven, fridge, and many more. Thermocouple. Thermocouple is a sensor which used to measure the high temperature up to just below the melting point of the metal. It is consists of two wires made from a dissimilar metals which are fixed at one of the ends, creating a junction. When this junction experiences a change in temperature, the voltage here is created, which we can measure it. The uses of it. We use it in the gas ovens and heaters. Thermal expansion. What is the meaning of thermal expansion? Most of the solid material here will expand when we heat it. So, its dimension will increase. This temperature is called thermal expansion. In the figure A, the bar here is cold, so it will fit the gap of the measuring device. In figure B, when we heat it, it will expand and no longer fit the gap of the measuring device. We use the thermal expansion in rivets, which used to join two steel plates together, and in recording TV programs, and adding USB and FireWire ports, and in connecting to a fast hard disk and adding media card readers and getting mobile broadband. Expansion of gases at constant pressure. What is the difference between expansion and contraction of gas? When the gas is cooled at lower temperature, the molecules here move slower and have less energy, okay? So they are close to each other, causing the volume to decrease. When we heat the gas here, the molecules gain more energy and move faster and farther apart. This causes the volume to decrease. This is the difference between contraction and expansion of the gas. Activity 10.2, it is observing expansion for the solid and liquid and gas. First one, this is a steel ring and that is a steel pole. At first, when this pole is cold, it will go or pass through the ring very easy. When it is hot, it will not pass through the ring. The second one, this is the expansion of solids. What about the expansion in liquids? This is a flask to contain water, okay, filled with water, and then fitted with a bung and a tube. When this flask is placed in a hot water bath, the water will rise here up inside the tube because of the expansion of the liquid. What about the third one? This is a flask contain air only and fitted with a bung and a tube. When it is placed in a hot water bath, the bubbles will coming from the end of the tube. This is because of the expansion of the gas, of the air. Your homework will be 10.1, 10.2, 10.3, 4, and 5 in the course book. Thank you.